All right, a little intro music there. All right, here we go. And talk about the brain. Okay. There's a little picture of, that's Homer Simpson's brain. Let's look into Homer Simpson's brain, see the different parts. It's basically what we're going to talk about is parts of the brain. Actually, that's not what the parts of the brain are like. We have three brains. And we're going to talk about all three of these brains that are inside your head. So there is the hind brain, which is at the rear base of the skull, right down here. Okay. It contains the cerebellum, the medulla, and the pons, and it pretty much controls involuntary functions, things like heart rate and stuff like that. Now, we'll talk about the cerebellum, the medulla, and the pons. The cerebellum is at the base of the spinal cord, as you can see. It controls posture and balance, but that's not the only thing. I mean, there's other things that each of these parts actually control, but I'm going to give you the basics here. So if you want to become a psychologist or something like that, or a neurosurgeon, you're probably going to need to learn every little aspect of the brain. But just in high school psychology, you don't have to learn it all. You can, though. You can go above and beyond if you would like. The medulla oblongata, it controls breathing, reflexes, heart rate, and blood pressure. And the pons is a bridge from the spine to the brain, and it controls body movement, attention, sleep, and alertness. And you can see where these are located. So this whole little area is the hind brain. It's in the hind quarters of the brain. I guess it's a butt brain. The midbrain alerts the rest of the brain to incoming signals. So everything comes into the midbrain, and then it tells the rest of the brain, hey, we got information coming in. It does this really, really fast. This involves vision and hearing as well. One of the things that is in the midbrain is the reticular activating system. It begins in the hindbrain and rises through the midbrain to the lower part of the forebrain, and is very important for attention, sleep, and arousal. One of the things that makes us alert, it's one of the reasons why you can lay there and go to sleep if you live by a road, which I live by Running Horse Road, and we have constant traffic. Well, it just kind of normal noise, and I don't really, it doesn't really bother me, and it doesn't wake me up in the morning, but a sudden noise might wake me up or something like that. If I heard something that didn't sound normal, that would probably wake me up. And that's my reticular activating system. We are awake when we sleep, although you guys sleep so hard because you are sacked out, probably don't have enough sleep and all that stuff. Alcohol will reduce this because it just puts you away. You pass out, and your reticular activating system doesn't work. Now, the forebrain, this is part of the brain that covers the brain's central core. There's kind of stuff inside this area. And then you have the cerebral cortex, which is the part of the brain that you guys probably consider the brain. There's things inside of it. The thalamus serves as a relay station for all sensory stimulation. So all of your senses go into the thalamus, and then it goes into the brain to figure out what we need to do and see and stuff like that. It has all the senses except smell. The hypothalamus, it controls hunger, thirst, and sexual behavior. This is kind of our biological or animalistic thing, the hypothalamus. And the hypothalamus also controls body temperature. The part about hunger, the hypothalamus is what makes us hungry. What happens is our body needs nutrition. And to get nutrition, we have to eat. And so the hypothalamus will send hunger signals to your stomach and you feel the feeling down in your stomach like, man, I'm hungry. I want something to eat. And so it kind of makes you go eat. It also will turn off the hunger signal and give you a full signal. And so if you are eating and eating and eating, and then all of a sudden it's like, hey, we're done. You got enough? Let's stop it. Now, my hypothalamus doesn't work that well. Unfortunately, my children, when we go out to eat, they don't finish their meal, and I pay for it. And I get the bill, and I look at it, and I'm like, what the heck? And I look at my kids' plates, and they haven't eaten everything. So I start reaching over and grabbing and eating on their thing, even though my hypothalamus is saying, stop eating. That's where it becomes kind of a problem. Also, when there's ice cream around, my hypothalamus doesn't kick in. Just to let you guys know, they have severed the part of the hypothalamus that sends the hunger signal on little rats. And these rats will not eat because they don't feel hungry, and they actually end up starving. Then they will actually cut the part of the hypothalamus that sends the full signal. Sorry. If they send the full signal, the rat always feels full and it won't eat. If they cut the part that to where I'm messing this up. Sorry. If they cut the hunger signal so it never gets the hunger signal, it won't eat. If they cut the full signal, the rat will eat and eat and eat and eat. It constantly eats, and it gets huge. And many of these rats will overeat and almost kill themselves. And some of them have died because of this. So hypothalamus is pretty important. It's that biological, animalistic part of your brain. The limbic system, evolutionary psychologists believe that the limbic system controls behavior that is necessary for survival. And this is more biological stuff like hunger and sex and aggression, emotion. We have to go carry on the species. We remember, like if we eat something bad, we remember it. It controls our emotions and our aggression. Like when things make us happy, we remember that. We come to it. When things make us upset, we remember that, and we stay away from things like that. The cerebrum, it's the cerebrum and the cerebellum, or the cerebral cortex. The cerebrum is this whole thing, and then the cerebral cortex the cerebrum is the outside part of it. And then you have the cerebral cortex, which is this outer layer of the cerebrum. And this is our higher level thinking stuff. And one of the things about the cerebral cortex is it's divided into lobes. All right. And we have 4 lobes of the brain: the frontal lobe, the parietal lobe, the occipital lobe, and the temporal lobe. Now, we're going to get into the frontal lobe more here in a bit, but it deals with judgment planning, Broca's area, body movement. It censors the things that, like, it keeps us from doing the things we kind of think about doing. Like, hey, I think I'm going to try this. And we're like, nah, I don't think that's a good idea. That's the one that tells us it's not a good idea. It's the problem with you guys. You're teenagers. Your frontal lobe is not properly developed. It won't develop until you're like 24, 25 years old. It's why you do some of the stupid things you do. It's why when you do something stupid, your parents ask you the question, what were you thinking? And you really don't know what you were thinking. Well, here was the problem. Your frontal lobe's not properly developed. You say dumb things, you do dumb things. You know, it's like you watch Barstool Sports and these people will jump off of a roof into a swimming pool and they miss the swimming pool. Like, I'm not jumping off a roof into a swimming pool. It's why some of you have probably driven your car 100 miles an hour. Okay. Why? There's no purpose, but our frontal lobe isn't developed. All right. Mine is. I'm not going to drive 100 miles an hour at 47 years old. The parietal lobe contains the sensory cortex. You deal with things like touch and pain, a lot of sensory stuff. It also deals with spatial and visual perception. The occipital lobe is in the back, and it actually deals with vision. I kind of tap it, and you can almost feel it in your eyes when you tap the back of your head. The temporal lobe has the Wernicke's area, which deals with language, memory, hearing, and sequencing and organization. Now, our brain is also has a left and right hemisphere. The left hemisphere of the brain and the right hemisphere of the brain actually do different things. The left hemisphere of the brain controls the right side of my body. The right hemisphere of my brain controls the left side of my body. And anything I visualize in the right hemisphere of my body is controlled by the left hemisphere. The other thing about this is our language is in our left hemisphere of the brain. And so when something goes into the right hemisphere, that message goes into the left hemisphere and deals with language. And then I'm able to say things about it. If it goes in the left hemisphere, it sits there and stays in the left hemisphere, and I say things about it. Our brain works together. All right. So our left hemisphere of the brain is more analytic thought, language, logic, more science and math stuff. Our right hemisphere is more creativity, art, music, and stuff like that. It's our creative side. But we use the whole thing. Okay. Now, there was a video you guys hopefully watched, and if you have not, you should right now go back and watch it. It's about a guy with a split brain. Our hemispheres are connected by the corpus callosum. It is this nerve fiber that goes and basically messages travel through the corpus callosum, and it aids in the transfer of information from hemisphere to hemisphere. Cutting the hemispheres make them work independently, and they do this because people have epilepsy and they have a ton of seizures, and it tries to reduce seizures. That video will show you how this guy gets information into the right hemisphere of the brain. It comes, or well, in the left hemisphere of the brain, things are flashed on the right side. Well, he can say what it is, okay? But if something flashes over here on the left side of his, and it goes into the right hemisphere, he can't identify what it is, but he'll draw a picture of it. And then he looks at his picture and it's like, oh, yeah, that's whatever it is. Watch the video. It's kind of interesting, and see the experiment they do. You don't have to watch the whole thing, but see the experiment they do. Now, one of the things they do is they flash a picture of, and now that I see this, I have this backwards. If they flash it on the right side, they can describe it. If they flash it on the left side, I got this backwards. They flashed it on the left side, they couldn't describe what it was, but they would become flushed and embarrassed with whatever it was. One of the things about the occipital lobe, damage to one portion affects a person's ability to differentiate an object from another similar object, because some functions require the involvement of the cerebral cortex to interpret sensations. So that's one of the things that's on the objectives that I'm sure I put that on there because it's awful random. Something about the occipital lobe. It's a question. I don't say anything, I guess. So studying the brain, one of the things you got to understand is some of those historic psychologists that we talked about, like Sigmund Freud, those guys never got to look at pictures of the brain. They never got to see the technology that we have today. One of the things that we have is recording an electroencephalograph, or an EEG. This is where electrodes are inserted into the brain to record electrical changes when the neurons fire. And you can tell what parts of the brains are actually working and how hard it's working. They can also stimulate neurons and trigger memories in people by stimulating neurons. The problem with this is you can't control what memories are going to come up. So it varies from person to person and day to day. You can stimulate neurons in my brain and cause a memory to pop up, but you don't know what memory is going to pop up. I can do it tomorrow and get different memories. Same thing with you. So it's not very reliable research tool. Talking about lesions or cutting away or destroying parts of the brain, that's a lobotomy. And they do this by cutting. They take like an ice pick and they stick it in through their eye, and they go up and cut part of the brain. They cut the frontal lobe. All right. And they do this with very psychotic patients or mental institutions. They don't do it anymore. They did in like the 50s and the 60s. And it basically sedates that person. It almost turns them into somebody different. It changes their personality. And they started doing that because they learned from the frontal lobe because of the accident of Phineas Gage. Now, the video, if you would watch the video about Phineas Gage, that's very interesting. It talks about Phineas Gage. He had a big old long pipe go through his, it was about here, and went through his head, and it just fired off all the way through, went all the way out of his head. Before that, he was a real good guy. Afterwards, he was a jerk and very short-tempered, said inappropriate things. And the reason why is it went through his prefrontal cortex. It stopped censoring things that, you know how you think about something? Like right now you're thinking, this guy who's doing this video is an idiot. But you don't email me and say, this guy's an idiot. Your frontal lobe says, nah, don't do that. Let's not do that. All right. Well, when your frontal lobe is damaged, you might email me. Um, so, getting back to these images, and watch the video on Phineas Gage. It's like 5 minutes. It's pretty interesting. I think you'll like it. A computerized axial tomography or a CAT scan. They use. Some of you may have had this. Man, I'm getting all kinds of messages. Some of you guys might have had a CAT scan of your brain because you had a concussion or something like that. Maybe you were getting headaches. I don't know. So they use a CAT scan to look inside your brain and get a view of your brain. Positron emission topography is a PET scan. This gets pictures showing how different parts are being used, and they'll flash a picture in front of you, and if it might be a unpleasant picture, and see what part actually starts working. It might be a nice picture, and to see what part starts working. And magnetic resonance imaging is an MRI that studies activity and brain structure. So that basically takes care of section 2. I want you to read section 2. I want you to do that graphic organizer. You need to understand those parts of the brain. I'm not going to explain them a ton. This is some kind of, I don't know, it's not all that exciting of stuff. Watch the 2 videos. That's pretty interesting. Next time we talk, we'll get into section 3. That's about hormones, which is pretty interesting to deal with the hormones.